We're going to go over question number 2 from the hallway riddle that we did in class. But before I get to that actual question, I'm going to do just a quick review on lots of little solution chemistry things. So solutions, remember solutions are, we have some solute dissolved in a solvent. We're going to calculate concentration of the solution, how much solute is dissolved with molarity. So molarity is the same thing as concentration. We're going to find the moles of solute, that's the stuff that's getting dissolved, divided by liters of the total solution. So not the solvent, but the total solution. So in this example, I have 5.8 grams of sodium chloride. I need moles, not grams. So our first step is to convert our grams into moles. I have grams on the top. I want to get rid of it. I'm going to put grams on the bottom. I'm going to show my grams into moles, put moles on the top. I need the molar mass of sodium chloride in order to do this conversion. Sodium is 22.99. I'm going to round that to about 23. Chlorine is 35.45. I'm going to round that to about 35. So when I add 23 and 35, I get 58. Approximately 58 grams per mole is the molar mass of sodium chloride. So I'm going to put my numbers of grams here next to grams, and that's going to be per 1 mole, so 1 mole on the top. So now grams top and bottom cancel out, and we are left with 5.8 times 1 divided by 58. And this actually is some pretty easy mental math. That decimal, that almost the same number, is going to turn into 1 over 10, or 0.1 of a mole. And then I have 0.5 liters of solution, so 0.1 divided by 0.5, that's the same thing as 1 over 5. That's the same thing as 0.2, and we use big M, capital M for molar. So 0.2 molar is the concentration, molarity of the solution. So let's take that same solution, and now we're going to do this formula, which is our dilution formula. So let's say that I take my 0.5 liters of 0.2 molar salt solution, and I add more solvent to it. So now my formula M1 V1 equals M2 V2. M for molarity 1, V for volume 1. That's what we're starting with, and that's going to be my 0.2 molar from my original solution and 0.5 liters, our original volume. I'm going to set that equal to M2 is what I'm trying to find. I don't know what that is yet, so I'm just going to leave my M2, and then I'm going to multiply that by volume 2. So this one's kind of tricky because you're like, well, volume 2 must be 0.5 liters. That is not correct because it's actually 0.5 more liters. So I had 0.5 and now I have 0.5 more. That's a total of 1 liter. So my new volume, V2, is 1 liter. I'm going to multiply these two guys. I'm going to get 0.2 times 0.5 is 0.10. 0.1 with sig figs, moles times liters, and that's equal to molarity 2 times 1 liter. Divide both sides by 1 liter. That just cancels out. I lose the liter unit on the other side, and so our new molarity is 0.1 molar. And that makes a lot of sense because we started with 0.2 and I doubled the volume, and so I chunked the concentration in half. New molarity 0.1 molar. All right, so let's look at the much harder bit of formula is pH. So if we're talking about acids and bases, we're going to talk about pH quite a bit. And the reason is because often we have these crazy multi-zero numbers, and pH just helps us not worry about all those zeros. So it's just easier numbers to work with. So pH is the negative log of the hydrogen ion concentration of the solution. So we're going to talk about logs real fast. If you are a log expert, feel free to ignore all of this. If you're like, I could use a little review about logarithms, then don't skip ahead in this part of the video. So logarithms, basically what we're doing is trying to figure out what an exponent is. What is the exponent? So when we look at exponents, most of the time we'll have some base. So here's our base. I'm going to raise it to some exponent, and that's going to equal to some number. We call it the argument. So we could have like base of 2 raised to the 3 exponent. That's going to be equal 2 times 2 times 2 is 8. That would be our argument. When we do logarithms, I basically have 2 to some power is equal to 8, and I have to figure out what is the power. But instead of writing it like this with a little square where the exponent is, what we do is we say log base 2 of my argument equals what's the exponent. So 2 to what power is equal to 8? 2 to what power is equal to 8? And the answer is 3 because my exponent is 3. So when we are working with pH, we're going to actually use what's called the common log, which means that base is going to be 10. And so anytime you don't see a base there, like here I had base 2, if you have an invisible base, you're going to assume that it's base 10. This is the common log. The other weird thing, we're going to throw a negative sign in front of it. So this question, the hydrogen ion concentration of a solution, oh, I should have put a unit in there, sorry, molarity, 0.000001 molar, what's its pH? If I was writing about this solution and I had to keep writing all these zeros, it would get super tedious, and I would probably make a mistake and lose a 0 or add a 0. So pH allows us to just work with more reasonable numbers, fewer zeros. So I'm actually going to convert this to scientific notation. So this is going to be 10 to the minus 1, 2, 3, 4, 5, 6. 10 to the minus 6 molarity is what this number is just in scientific notation. And I'm putting that into scientific notation because now all I need to do is find the exponent on the 10, and I already have an exponent on the 10. Where we're looking for log base 10 of 10 to the negative 6. What exponent is on the 10? Like literally, the exponent is right there. So our answer is going to be negative 6. But remember that pH is the negative log, so it's going to be the negative 6. Our pH is going to be 6. Good. So I'm going to do it one more time. If you've got this, feel free to fast forward the video. If you don't got this, we're going to listen one more time. Make some more space here. All right. So again, we're going to turn this number into scientific notation. I do this by going 1, 2, 3, 4, 5, 6. Remember that your decimal place needs to be after a ones place. So this number is equal to 10 to the minus 6. If I find the negative log, the common log of 10 to the minus 6, I'm trying to figure out what is the exponent on the 10. This is the exponent on the 10. And so our answer is going to be negative 6, except it's negative 6, which will give us a positive 6 pH. Sometimes you do not have these lovely numbers. Sometimes you'll have something like negative log of 0.0237. Get your calculator out. That's the advice that I have for that one. But if it's something nice, a 1 base 10, 1 number, then you can just do it in your head. Good. So that's the pH. pH is going to be 6. What's the pOH? So kind of a cool deal. So our solutions come with pHs and pOHs. Hydrogen ion concentration tends to be higher in acids, and then hydroxide concentration tends to be higher in bases. And so what's super cool is this H plus and OH minus, because water is basically H plus and OH minus, right? So here's water, H plus and OH minus. So in solutions, these guys are like in a super cool balance where the product of their two concentrations is equal 10 to the minus 14. So if my pH is 6 because the hydrogen ion concentration is 10 to the minus 6, then this guy's concentration is going to be this times this equals 10 to the minus 14. So this is going to be 10 to the minus 8. So whatever the hydrogen ion concentration is times the hydroxide ion concentration, the product is always going to be 10 to the minus 14. And if we do some super cool exponent rules, we know that when we multiply by same base, then we're just going to add the exponents. -6 and -8 makes -14. When I do pHs, I'm getting rid of that negative, right? Because it's the negative, and so it turns into positive most of the time. We can have negative pHs. It's uncommon. It doesn't happen in nature, but we can definitely make it happen in the lab. But most of the time, our pHs are going to be positive. So anyhow, because of that -6 and -8, here's my 6. The pOH is just going to be 14 minus the pH. So pH plus pOH is always going to add up to 14. So since our pH is 6, our pOH is to be 8, because 6 plus 8 equals 14. And this again just goes back to that concentration, because the product of the H pluses and the OH minuses always multiply to make 10 to the minus 14. Now that we have a good handle on pH in general, let's talk about finally that problem from the hallway. So what's going on here? I want to find the I need to find the hydroxide ion concentration. This polyatomic ion is hydroxide. I need to find the polyatomic ion concentration. These guys tell us find concentration. This is our shortcut for we're talking about concentration molarity. And what I know is that the pH is 3.7. The pH is 3.7. Remember that the pH is the negative log of the hydrogen ion concentration. The pOH is the negative log of the hydroxide ion concentration. Since I'm looking for the hydroxide ion concentration, it's actually going to make more sense if I flip over to pOH. Remember that pH plus pOH equals 14. So if my pH is 3.70, then my pOH has to be 14 minus 3.70, which is going to be 10.30. Good? Good. So this is my pOH. So pOH is going to be 10.3. This is the negative log, common log, base 10, of the hydroxide ion concentration. Remember that when we do logarithms, we're figuring out what's the exponent, in our case, the exponent on a 10. This is the exponent because this is what's the answer to the logarithm problem. This is our exponent. The pH and the pOH, these are exponents. So when I go backwards, I'm trying to go backwards to my concentrations, all I have to do is put that number back as an exponent on a 10, but a negative exponent on a 10, because pH is negative log and pOH is negative log. So we're going to take this, which is the exponent, and we're going to put it back on a 10. I'm going to take my 10, I'm going to put this number back as an exponent, because logarithms are negative logs. I'm going to make my exponent negative. So 10 to the negative 10.3 is my hydroxide ion concentration. This is not a match for any of my answer choices because that's really weird to have decimals in your exponent. But if you get out your calculator and you type in 10 raised to the negative 10.3 power, or you can just do scientific notation, the EE button, negative 10.3. Make sure you use negative and not minus. Don't use the minus button, use the negative button. You're going to get this answer right here, 5.0 times 10 to the negative 11 molar. Good, good. Let me know what questions you have.